Our solar system is a vast and dynamic place. While we often marvel at the beauty of the planets and stars, there are hidden dangers lurking in the darkness. These dangers are asteroids, and they are everywhere. Millions of these rocky remnants from the solar system's formation zip around our sun. Many asteroids are too small to pose a threat. However, some are large enough to cause significant damage if they collided with Earth. We've identified many asteroids, but there are still millions more that we haven't found yet. These undetected asteroids are the invisible threats in our cosmic backyard. Finding and tracking these invisible threats is a constant challenge. Scientists use powerful telescopes to scan the skies. They look for any object that moves differently than the stars. They are constantly improving their methods to detect and track these space rocks. It is a race against time to find them before they find us. Among the many asteroids in our solar system, Phaethon stands out as particularly intriguing and potentially dangerous. Named after the son of the Greek sun god Helios, Phaethon is massive, about 6 kilometers in diameter. It's large enough to cause regional devastation if it collides with Earth. Phaethon's highly eccentric orbit brings it closer to the Sun than any other named asteroid. This orbit heats its surface to 750 degrees Celsius. The intense heat causes Phaethon to shed dust and debris. While there's no immediate danger of collision, its orbit can change over time. In the vast, icy outskirts of our solar system, beyond the orbit of Neptune, lies a realm of celestial wanderers known as the Oort cloud. This region is home to trillions of icy bodies, remnants from the early solar system. Occasionally, gravitational interactions between these objects or the influence of passing stars can nudge one of these icy bodies out of its distant orbit, sending it hurtling towards the inner solar system. Such is the case with Comet Bernardinelli-Bernstein, a behemoth of a comet discovered in 2021. This colossal comet, with an estimated diameter of at least 120 kilometers, is one of the largest objects ever discovered in our solar system. To put its size into perspective, it is larger than the state of Rhode Island. Fortunately, Comet Bernardinelli-Bernstein's current trajectory does not pose a threat to Earth. However, its discovery serves as a stark reminder of the vast and often unseen dangers that lurk in the depths of space. Objects of this size, if they were to collide with Earth, would have catastrophic consequences, potentially wiping out life as we know it. In the grand cosmic ballet of stars, our sun is just one of billions dancing around the center of the Milky Way. Occasionally, stars pass close to one another. One such neighbor, Barnard's star, is approaching our solar system. Traveling at 90 kilometers per second, it's the closest single star to our sun. In 10,000 years, it will pass within 3.8 light years. Its gravitational pull could disrupt the Oort cloud, sending comets towards the inner solar system. In the vast expanse of space, between the fiery brilliance of stars and the cold, rocky planets, lies a class of celestial objects known as brown dwarfs. These enigmatic objects are often referred to as failed stars, as they are not massive enough to sustain nuclear fusion in their cores, which is the process that makes stars shine. Brown dwarfs are significantly larger and more massive than planets, but they are smaller and cooler than stars. Because they emit very little light and heat, they are incredibly difficult to detect. They lurk in the darkness of space, their presence often only betrayed by their gravitational influence on nearby stars or by their faint infrared emissions. While astronomers have identified thousands of brown dwarfs in our Milky Way galaxy, they believe that many more remain undetected. Some of these undiscovered brown dwarfs could be lurking closer to home than we think. The gravitational pull of a passing brown dwarf could disrupt the orbits of comets in the Oort cloud, potentially sending some on a collision course with Earth. In the constellation Orion the Hunter, a celestial giant marks its presence with a fiery red glow. This celestial giant is Betelgeuse, a red supergiant star nearing the end of its life. Betelgeuse is a star living on borrowed time, its core running out of fuel to burn. When a star much more massive than our sun reaches the end of its life, it goes out with a bang, a spectacular explosion known as a supernova. And Betelgeuse is destined for such a fate. Astronomers estimate that Betelgeuse is within its final 100,000 years of life, a blink of an eye in cosmic terms. When Betelgeuse does finally explode, it will be a truly awe-inspiring event. The supernova will be visible from Earth even during the day, shining brightly for weeks or even months. While Betelgeuse is relatively close to Earth in astronomical terms, it is still far enough away that its supernova explosion will not pose a direct threat to life on our planet. When stars exhaust their nuclear fuel, they leave behind remnants that are incredibly dense and often incredibly strange. These stellar remnants, white dwarfs and neutron stars, are the products of stars that have died, their cores collapsing under their immense gravity. White dwarfs are the remnants of stars similar in mass to our Sun. These objects are incredibly dense, packing the mass of the Sun into a sphere roughly the size of Earth. Neutron stars, on the other hand, are the remnants of much more massive stars. They are even denser than white dwarfs, cramming the mass of two suns into a sphere no larger than a city. While white dwarfs and neutron stars are fascinating objects in their own right, they can also pose potential dangers. White dwarfs, in particular, can become dangerous if they are part of a binary star system. If a white dwarf is close enough to a companion star, it can start to siphon off material from its companion. In the vast expanse of the cosmos where stars are born and galaxies collide, some of the most powerful events in the universe unfold. Among these cosmic spectacles are gamma-ray bursts, often abbreviated as GRBs, which are brief but incredibly intense flashes of gamma rays, the most energetic form of light. GRBs are thought to be caused by the most cataclysmic events imaginable: the collapse of massive stars into black holes, the collision of neutron stars, or the merger of a black hole and a neutron star. These events release an unimaginable amount of energy in a matter of seconds, more energy than our Sun will emit over its entire 10 billion-year lifespan. Fortunately, GRBs are incredibly rare events, and the vast majority occur billions of light-years away, posing no threat to Earth. However, if a GRB were to occur within our galaxy, and if Earth were unfortunate enough to be in the path of its powerful beams of gamma rays, the consequences could be catastrophic. In the distant reaches of the universe, billions of light-years away, shine some of the brightest objects in the cosmos: quasars. These celestial powerhouses are not stars but rather the active galactic nuclei of distant galaxies, powered by supermassive black holes billions of times more massive than our Sun. As matter falls into these supermassive black holes, it forms an accretion disk, a swirling disk of gas and dust heated to millions of degrees. This heated material emits radiation across the entire electromagnetic spectrum, from radio waves to gamma rays, making quasars some of the most luminous objects in the universe. While quasars are incredibly distant, their immense power means that their radiation can still be detected here on Earth. However, this radiation is so faint that it poses no threat to life on our planet. In fact, quasars are so far away that they are more of a curiosity than a concern. As we have explored the many dangers that lurk in our solar system and beyond, it is clear that we live in a dynamic and often unpredictable cosmos. While the vast majority of these dangers are incredibly rare, the consequences of even a single impact event could be devastating. This underscores the importance of vigilance and continued research in the fields of astronomy and planetary defense. By scanning the skies for potentially hazardous objects, studying their orbits and compositions, and developing technologies to deflect or mitigate potential threats, we can better protect our planet from cosmic disasters. The more we understand about the universe around us, the better equipped we will be to face whatever challenges the cosmos may throw our way. Investing in space exploration and research is not just about satisfying our curiosity about the universe, it is also about safeguarding our future. The knowledge we gain from studying the cosmos can help us protect our planet and ensure the survival of humanity. As we contemplate the vastness of the universe and the countless celestial objects that inhabit it, it is humbling to consider our place in this grand cosmic tapestry. We are but a small planet orbiting an average star in a galaxy teeming with billions of other stars, and our galaxy is just one of trillions of galaxies that make up the observable universe. While the universe may seem indifferent to our existence, it is also a source of endless wonder and inspiration. By studying the cosmos, we gain a deeper understanding not only of the universe around us, but also of ourselves. We come to appreciate the fragility of life on Earth and the importance of preserving our planet for future generations. The journey of exploration and discovery is never-ending, As we continue to explore the cosmos, we will undoubtedly encounter new wonders and new dangers, but by embracing the spirit of scientific inquiry and working together to protect our planet, we can face the future with courage and hope.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.